So at this point, you have a whole bunch of possible rules to use if you have right triangles to find missing sides and missing angles. You've got altitude, um, hypotenuse rules, you've got the leg hypotenuse rule, the special right triangle, so the 30, 60, 90, and 45, 45, 90 rules. You've got, oh geez, you've got Pythagorean theorem, you've got SOHCAHTOA, the trig ratios, SOHCAHTOA. And it's a ton of stuff that you can use, and it's probably not so much a problem for you at this point using them if you know which one to use. The problem is which one do you use, and that becomes the issue. And sometimes you can use more than one. It's just that sometimes you need an exact answer, and often if you need an exact answer, then the altitude hypotenuse rules or the special right triangle, the 30, 60, 90, 45, 45, 90 are the way to go because they'll give you an exact answer. You're just multiplying by square roots of things. And if you're using SOHCAHTOA, using trig ratios, then you often end up with decimals for answers that you need to round. So it depends on what you need to do. Is an exact answer necessary, or is rounding to the nearest tenth or to the nearest hundredth or thousandth good enough for what you need? So that's one reason you would make a decision about which rule you would use. Another reason that you might use one or the other has to do with the information that you're given or not given, and how much time you have, and whether or not you have a calculator. So we're going to go through at least the first page of this handout, and all we're going to do is decide what rules you could use and why. And then we'll go back and I'll do some of the problems for you in the next video or two. So we're just going to decide which of the rules that we would want to use for each one of the problems and talk a little bit about why I would choose to use one rule or another. All right, so look at problem number one. I've got, let's see, I've got a leg, and I've got another leg that's missing the x, right? 15 and x, those are both legs. I've got 25 degrees. Well, I definitely can't use altitude hypotenuse or leg hypotenuse because I don't have a triangle, right triangle that is divided by an altitude running down the middle. So I don't have something like number two, where I have a right triangle and the altitude drawn. All I have is one triangle with one altitude. So I'm kind of stuck using 30, 60, 90, 45, 45, 90, Pythagorean theorem, or SOHCAHTOA, but once again, I can't use 30, 60, 90, the special right triangles, because this is the 25, 75 right triangle, no, 25, 65 right triangle, which is not one of the special ones, so it doesn't have any special rules. So that means I'm down to either Pythagorean theorem or trig ratios, SOHCAHTOA. Well, I can't use Pythagorean theorem because even though I'm looking for a side, I only have one. I just have that 15. And Pythagorean theorem requires that you use at least two sides. So that means that I am going to be using SOHCAHTOA here. So let me just type that in, SOHCAHTOA, to find that missing side. Now let's take a look at number two. All right, number two, the first thing I'm noticing about this is it's one of those right triangles that's split down the middle with another altitude. So I know I could use the altitude, hypotenuse, leg hypotenuse rules for sure. I can't use the special right triangle rules at this point because I don't know if I have a 30, 60, 90 or an isosceles triangle of 45, 45, 90. Pythagorean theorem, well, that would be a possibility, but if I'm looking at this, if this little right triangle right down here, I have the altitude 18, but I really only have I only have that one side of this right triangle, this little part of the right triangle, so I really can't use Pythagorean theorem, and it looks to me like I don't have enough information to use SOHCAHTOA. So I'm going to use the altitude hypotenuse or leg hypotenuse rule. Now it's between these two. And I am going to choose altitude hypotenuse because I have the altitude and it's being at splitting the hypotenuse into two pieces. So I am going to use the altitude hypotenuse rule for number 2. Let's take a look at number 3. So number 3, I've got a hypotenuse 21, I've got one of the legs 17, and I need to find an angle. All right, well, it's not going to be altitude leg, it's not going to be a special right triangle. I could use Pythagorean theorem here. I've got two sides, but I'm not looking for a side. I'm looking for an angle. So this is going to be a SOHCAHTOA problem. Number 4. Number 4, I've got a couple of choices. I could definitely use a 30, 60, 90. It's a special right. I could do 30, 60, 90 rules here. But I could also use trig ratios if I wanted to. So I have some choices here. SOHCAHTOA is another possibility. Won't be using Pythagorean theorem because I only have one side, the 20. I don't have anything over here on this other leg. Number 7. Oh, number 7. I've got a leg 7 and I'm missing the hypotenuse, but it's 45 degrees, so I know I could use 45, 45, 90. And that probably will be the fastest. I can use, if I want, SOHCAHTOA here. That will also work. The trig ratios will be probably a little bit more work, but the 45, 45, 90. But if for some reason I'm not remembering the rule or can't find my card and I have a calculator handy, SOHCAHTOA will work. Number 6. Number 6, I'm looking for an angle, and I really don't know enough about this triangle to know if it's isosceles or not. I could use Pythagorean theorem to find that missing leg, and maybe I'd find out that it's isosceles, and I would know that this is going to be 45, 45, 90, but probably not. And because I'm looking for an angle, I can't use Pythagorean theorem, so this is going to be a trig ratio problem. SOHCAHTOA. Number 7. Oh, there's the familiar triangle. Split down the middle by an altitude. And because I am looking for the leg over here, I don't have anything on the altitude. There's no number. I'm not looking for it. I am going to use the leg hypotenuse rule. Notice that I'm not going to use Pythagorean theorem here because I don't really have enough information to get the missing part. And number 8 is going to be another SOHCAHTOA. Take a look at the back. Number 9. Ooh, where did I end up here? Sorry about that. Number 9. Oh, I'm missing one side of a right triangle. And look at that. I've got two other sides. This is a great place to use Pythagorean theorem. A squared plus b squared. Number 10, I've got a 60-degree angle. Oh, this would be a great place to use 30, 60, 90, a special right. Number 11, this one. What do you think? Hypotenuse leg, or leg hypotenuse rule. Number 12. Got two sides marked the same. Probably an isosceles right triangle. Let's use special right, 45, 45, 90. Number 13. Number 13. Oh, this angle, by the way, should be written on the inside. So if you want to scribble it out on your paper and just pop it right into the triangle, that's probably a great idea. So 49 degrees goes with the angle that's inside the triangle. This is going to be SOHCAHTOA. And the reason is it's not a special right. It's not 30, 60, 90. It's not altitude leg, hypotenuse leg, because you don't have an altitude running down the middle of the triangle. It's not going to be Pythagorean theorem because I only have one side and I need two numbers to plug into Pythagorean theorem. Number 14. Number 14 is going to be an altitude hypotenuse rule. And I'm using altitude hypotenuse because I have a right triangle that's split into two smaller right triangles with an altitude. I'm going to use altitude hypotenuse instead of leg hypotenuse because I am not given a leg and I'm not looking for a leg. I am looking for the altitude. Two more. Number 15, two sides of a right triangle. I'm missing a third. Great time to use Pythagorean theorem. Number 16 is probably going to be an altitude, nope, a leg hypotenuse. Yes, leg hypotenuse. So I've got a right triangle with an altitude drawn, although I don't have a number on the altitude. It's drawn in there, and I am looking for a leg, and I have the parts of the hypotenuse, so I'm good to go with that one. So why don't you go ahead and try a couple on your own, and I will do some for you in the next video.